Hi, I'm Vander, Veen, and I'm here high above Golden, Colorado, home to the famous Coors Brewing Company, which you can see below me. But I'm not here to drink beer. Well, not just to drink beer. I'm here because Golden is also home to the National Renewal Energy Laboratory. The newly opened research support facility at the lab is one of the world's most energy efficient buildings and is designed to achieve net zero status.
Our standard for energy efficiency really is the ASHRAE standards, 90.1, and ASHRAE standard is a commercial standard that's out there for commercial buildings, and we're going to beat that ASHRAE standard by 50%. So this is going to make this building so energy efficient that we actually have the opportunity to add things like photovoltaic panels to try to make up the balance of the energy, if you will, to potentially make the building net zero energy. So what you see is a building that looks like a lazy H from the top, and it's also a very, very narrow building. It's only about 60 feet wide. Because of the layout of the building and the narrowness of the building, we're able to capture much more sunlight than we could normally. And that's really one of the key features, design features of the building, is letting, if you will, the energy needs define the form of the building, and that's exactly what happened in this case.
What makes the building so energy efficient is a combination of thoughtful design, creative architecture, an understanding of the natural environment, and clever repurposing of existing materials.
The windows, yes, there's a lot of windows, but it doesn't waste energy. They were actually sized specifically to meet the thermal characteristics of the building. This building is 100% daylit. You can walk through any office area, and what you're going to find is that there's windows everywhere. That allows us, if you will, to reduce the lighting load. And because we reduce the lighting load, we actually could reduce the air conditioning load. It's really, the building is made out of very standard materials. Concrete, you'll see everywhere. It's a great thermal skin for us and actually acts as a thermal battery.
In addition to solar panels on the roof, a portion of the exterior is covered in a large swath of corrugated metal, a technology developed at NREL known as transpired solar collectors. The wavy metal is punctured by thousands of tiny holes. The holes draw air in, and the sun-warm metal heats the air, which is then pumped underground into the RSF's thermal storage facility.
The nice thing about this is all the materials and all the techniques that we used in this particular building are actually available to anybody today. It all operates passively, so there's not a lot of very complicated technologies. What we've done here today can be actually duplicated by others.
Repurposed materials abound in the facility. Floor tiles are made of granite mine remnants mixed with epoxy, and the receptionist desk is made of ground sunflower seeds and laminate. Wood paneling that permeates the building is actually salvaged from trees killed by a devastating pine beetle infestation. There is no HVAC system here. Rather, piped water is either heated by the sun or cooled underground, which in turn regulates the temperature inside. Scattered throughout are transparent floor plates that provide a look at the inner workings of the system.
Other features that you're going to see that are really important in terms of this design is the use of radiant heat. It's about 1,000 times more efficient than air heating and cooling. And so we have roughly around 42 miles of radiant tubing that circulate water, chilled water or heated water through the skin of the building.
For additional heating in the winter, heat from the data center is captured and reused. The office space bears witness to how effective the RSF's natural lighting scheme is. The sloped ceiling reflects the light directed inside down to the floor. Many windows also open. Most are computer controlled, but there are some employees can open at their choosing. A wall of windows offers a grand view on both ends of the building. Late afternoon here can often be the hottest part of the day. So, like a pair of high-end eyeglasses, the windows automatically tint themselves, letting light in and keeping heat out. Following my visit, I spoke to Golden Mayor Jacob Smith about what it means to him to have one of the world's premier green buildings in his town.
It's an impressive building for a bunch of reasons. Part of what's so cool about that building is that one of the lessons that they shared with us is that they were able to build it at a comparable square foot cost to other Class A but less energy efficient space. And one of the take-home lessons that I understood is you got to establish those parameters on the front end. But if it's very clearly part of the design from the beginning, you can build buildings that are that cutting edge and that efficient and that just nice a building for a cost that's comparable to anything else that's going up in the same class. And part of what was so cool was how clever, so much of what they did in that building isn't really complicated high tech. It's just being really smart about the design. So they weren't so much high tech as they were just really smart and thoughtful. And then they've got a space that's not only incredibly efficient, but it's also really, really nice workspace. Who on earth wouldn't want to work in that building?
That was the point that Baker really wanted to drive home. This facility isn't beyond anyone's reach to duplicate. Rather, it was built precisely so others can copy what NREL did.
The lasting value of this building is really demonstrating that we can do projects like this today using today's materials and today's techniques at costs that are comparable to today's commercial buildings. 10 years from now, what we want people to do is look back to the research support facility and say, this is where the nation's move toward highly energy efficient design started, and these are the folks that actually demonstrated it could be done.